In this lesson, we're going to go over linear modeling. Specifically, we'll learn to apply our understanding of linear equations to situations that can be modeled using linear equations. So just as a review, slope-intercept form of a straight line is y equals mx plus b, where m is the slope or rate of change, and b is the y-intercept or the starting point for x equal to 0. For linear functions, they make a straight line graph. One of the qualities of a linear function is that the rate of change stays the same, meaning the way you get from one point to another is you always use slope each time. The greater the slope or the rate of change, the steeper the slope of the graph. Okay, so rate of change is calculated by change in y over change in x. Or if we're thinking about linear functions in terms of the independent variable x and the dependent variable y, the rate of change could also be known as or described as change in dependent variable divided by the change in the independent variable. So with linear modeling, it's helpful to identify the independent variable x. Usually if there's some sort of time involved with the situation, time is usually independent, doesn't wait for anybody, and then whatever you're calculating depends on time. And so y is your dependent variable. Identify the rate of change or the slope, and this is typically something per something else, or whatever is climbing or falling in the problem by the same amount each time, and then identify the starting value, which is b. So we've talked about y equals mx plus b as slope-intercept form of a straight line, but if we think about x in terms of independent variable, which might help in the context of these problems, and y in terms of dependent variable, then your equation can become dependent variable is equal to your rate of change times the independent variable plus the initial value. So instead of having y, we've replaced it with the dependent variable. M is your rate of change, the independent variable is x, and then you have the initial value. So example 1, my dog weighed 0.5 pounds at birth and weighed 7 pounds 6 months later. Based on these two data points, find a linear function that describes how weight varies with age. Use your function to predict my dog's weight at 12 months and 24 months. Comment on the validity of this model. Okay. So our independent variable in this case would be age or number of months. Okay, usually time is your independent variable. Okay. Our dependent variable is how much the dog weighs. And then our starting value, so it says at birth, my dog weighed 0.5 pounds. So that would be the starting value. Okay, so we would, since our independent variable is dealing with time, at birth, that's time equals 0, starts there. This would be 0.5 pounds. Okay, and when you're given information like this, you need to make them into x and y pairs or independent comma dependent variable. And so the first point at 0, my dog weighed 0.5 pounds at birth. This would correspond to months are 0 and weight is 0.5. And then 7 pounds 6 months later, 6 months later is our x or our independent variable, comma 7. And so to find the rate of change, you can think of it as change in dependent variable divided by change in independent variable. So our rate of change here would be 7 minus 0.5 over 6 minus 0, which would give us 6.5 over 6. You could turn this into a fraction or I guess a decimal if you leave it stored into your calculator. Let me take a look. In your calculator, this comes out to be 13 over 12. Okay. And so now what we can do is that we can use an equation to describe this model. So we're going to model my dog's weight as a linear equation. And it says where W is the weight of the dog and T is time in months. So when the problem gives you the variables to use, you must use those variables. Okay, so W is our dependent variable or plays the role of Y, so we're going to have W is equal to our rate of change, which was 12 over 13, I believe, or 13 over 12, other way. And we're writing it in terms of T, so instead of X we have T, and then plus the initial value, which was 0.5 or 1/2. So this is what our equation would look like. Next, we'll use this model. I think in the problem I said 24 months. We'll use this model to predict my dog's weight at 12 months and 24 months, and then we'll talk about the validity of the model. So at 12 months, my dog would weigh 13 over 12. T is 12 plus 0.5. This would give 13.5 pounds. And then at 24 months, we would have 13 over 12 times 24 plus 0.5, which would be 26.5 pounds. Okay. And so discussing the validity of this model, remember that with linear equations or even linear modeling, it's changing by the same amount each time, which when you're talking about a dog growing, one of the things to consider is they usually grow more when they're younger, and then they kind of level out. So one of the things is linear may not be the best because it's not changing the same amount over the period of time. And then two, the model can't go on forever. The dog will stop growing at some point in time. So those would be ways that you could discuss the validity of the model. Example 2, a group of climbers begin climbing at an elevation of 3,000 feet and ascend at a steady rate of 1,200 vertical feet per hour. This situation can be modeled by a linear function. Find the linear function that models the situation where E is the elevation of the climbers and H is the number of hours. Use this model to find their elevation after 3 hours. So we have time, which is typically the independent variable. Another way you can look at this is I look at it in terms of vertical feet per hour. And so our dependent variable is their elevation, or how high up they are. So the independent variable is the number of hours. The starting value, they begin climbing at an elevation of 3,000 feet. So here we're starting at 3,000. And then they ascend at a steady rate. Rate is right there, that's your slope, of 1,200 feet per hour. Okay, so when we use the equation, E is elevation and H is the number of hours. E is our dependent variable, so using the dependent equals rate of change times independent plus initial, we have E is equal to 1,200 times the independent variable plus the starting value. And so for this problem, we can find their elevation after 3 hours by using H is equal to 3. So their elevation would be 1,200, going to plug in 3, plus 3,000. So this would be 3,600 plus 3,000. So they would be 6,600 feet up. So that would be their elevation. So there's an application problem that I want to go over that deals with money. So in general, profit is equal to revenue, how much you make, minus cost, how much you spend. Okay, so let's say you spend $1,000 to start a cleaning company, which includes your startup costs and enough supplies to last for a year. Let's say you charge $250 for each cleaning. Write a linear function where P is the profit and X is the number of cleanings. Use this model to determine when you will break even and when you will have a profit of $2,000. So our independent variable here is going to be number of cleanings. Okay. Your dependent variable is your profit. Your profit depends on how many cleanings you do. Okay. So that's how one way you can think of dependent and independent. Starting value. You spent $1,000 to start this company, which means you're starting off in the negative. So the starting value here would be negative 1,000. And your rate of change, you charge $250 for each cleaning, so dollars per cleaning would be $250 per cleaning, if you want to write it that way. Okay, so for this example, when we write the equation, our profit is equal to how much we make times the number of cleanings minus $1,000. So we eventually have to recover that cost, that $1,000 that we invested at the beginning, in order to turn a profit. So let's answer a couple questions. So when will you break even? So break even means that you're not, you haven't earned money yet, but you're not in the negative anymore. So break even occurs when your profit is equal to 0. Okay? And so in this case, we would plug 0 in for P. We'd have 250x minus 1,000. So we'd add 1,000, which would give us 1,000 equals 250x, and then divide both by 250, and we should come up with x equals 4. So that means after 4 cleanings, you will break even. So you will have recovered the $1,000 that you initially invested in your company. Let's say you wanted to make a profit of $2,000. So we would plug P as 2,000 and do the same thing. And I'm out of room, so I'll leave this to you to make sure you solve in your notes. You add 1,000 to both sides, you divide by 250, and you should get x equals 12, which means it'll take a full year to first recover your costs and then to make a profit of $2,000. Okay? And I have it graphed here for you as well. So the starting point is at negative 1,000 because that's what you invest. So after 4 cleanings, it crosses the x-axis when y is 0. So this would be where you break even. Okay, and then if you want to know your profit, 2,000 would happen after 12 months or 1 year. Thank you for watching. If you have any questions, please feel free to reach out to me.